All right, guys, let me get this set up. There we go. So we are on to our next packet here, and I'm on the first notes page. We're going to do some radicals. So remember, the name for a square root symbol is a radical, and that's what this is referring to, is those square root symbols. And as you guys found out before, for square roots, sometimes we get a whole number, right, as our answer when we take the square root, and then sometimes we don't. We get a decimal. That's an irrational number. Well, what we're going to be simplifying today are these irrational numbers, the ones when we take the square root of them, we don't get a whole number. And the numbers that we can take a square root of to get a whole number as our answer, those are called perfect squares, as we've mentioned in class before. So what I'm going to do here to begin with is just list out the first 10 perfect squares. So the way I'm going to figure these out is just to work backwards. So the first perfect square would be whatever 1 times 1 is. 1 times 1 is 1. Okay. The second perfect square is whatever 2 times 2 is, right? So 2 times 2 is 4, and then 3 times 3 is 9, and then 16, and then 25, and then 36, and then 49, 64, 81, and 100. Okay, so those are my first 10 perfect squares, and I'm actually going to go one step further. Okay, I want us to do the first 15 perfect squares. And the way I'm going to do that is just, keep on continuing down the side here, right? So the first 10 are listed. I want to do the next 5. So what's 11 times 11? That's my next one, 121. And then 12 times 12, the next perfect square is 144. The next perfect square, the next two actually, it's the same 3 digits. You just switch the last 2 numbers. I'll show you what I mean. 13 times 13 is 169. 14 times 14, so the 14th perfect square, is 196. So it's kind of, if you remember 169, you can remember 196. You just flip the last 2 numbers for 14 times 14. And then 15 times 15, you got to figure anything that ends in a 5 is probably going to have a 5 in it, right? So 225 is my answer for 15 times 15. So now I have the first 15 perfect squares. Well, why did we do that? That's what's going to help us simplify these radicals. And then when I say these radicals, I mean these ones where I can't take the square root of the number and get a whole number as my answer. Okay? It says to simplify radicals, we're going to factor using the largest, now it's in capital letters already, but I'm going to underline it to make it stand out even more. The largest perfect square that is a factor of the number under the radical. And when we say a factor of the number under the radical, we mean it can multiply to get the number under the radical. Okay. Place the answer to the perfect square in front of the radical. So you can see what they did here for radical 96. They noticed that 16 goes into 96. 16 is a factor of 96. And 16, right here in our list of perfect squares, is the largest one that goes into 96. Right? So the thing I like to do, guys, the easiest way to check this is estimate about half of the number and then just check every perfect square under that. So like 96, close to 100. So half of that is close to 50. I check every perfect square under 50 to see if I can multiply it to get it to equal the number under the radical. Well, 49 would be the first one I would check. Well, 49 doesn't go into 96. So the next one, I just keep working my way down. 36, does 36 go into no, 36 doesn't go into 96 either. 25, we know 25s, right? 25 doesn't go into 96. And then we get to 16, and 16 does go into 96. It goes into 96 6 times, and that's how they came up with those 2 factors. And you can do the square root of 16. 16 is a perfect square, so I know the square root of 16 is 4. That's why that 4 is out in front. It's no longer under the radical. But 6, when I take the square root of 6, it's irrational. I get this very long decimal number. It's not able to be simplified past that. So that's my final answer, is just that 4 times radical 6, or 4 radical 6. Okay? I think it's easier to see us actually work through some together. So these next three examples, we'll work through them. Radical 40 is the example number 2. So I'm going to check my perfect squares. Half of 40 is 20, so I'm going to check every perfect square. I can erase my little 16 highlight there. There we go. I'm going to check every perfect square underneath 20, right? I just go to half and then check every perfect square under that. So the next perfect square under 20 is 16. Well, 16 doesn't go into 40. 9 is the next one. 9 doesn't go into 40 either. 4 is my next one. And 4 does go into 40. So I'm going to break this one down into its factors. So this is radical 4 times, now what would I have to multiply 4 by to get it to equal 40? Well, yeah, it's 10. So it's radical 4 times radical 10. And then, yeah, we can do that. We can do the square root of 4. The square root of 4 is 2. And then radical 10, you guys type that into your calculator, you know we get this long decimal number because 10 is not a perfect square. So it has to stay under the radical. And that's it. That's my answer. Whoops, draw my arrow to show that I brought it down as well. Right? I can do the square root of 4, so I can get that number outside of the radical. I kind of bring it out. The 10, can't do that. It's got to stay under the radical. All right, so for the next one, radical 32. Again, I'm going to take half of that and check every perfect square that's half or lower and just keep working my way down. Well, I don't have to work very far for this one, right? Radical 32, half of 32 is 16, and we just showed 16 is a perfect square. So that one, I didn't have to look very far. It's just radical 16 times, 16 times what? Oh yeah, it just said it was half, right? So it's 16 times 2. So it's radical 16 times radical 2 equals radical 32. And then I can do the square root of 16. The square root of 16 is 4. I can't do the square root of 2. It gives me this big long decimal number. So that's it. It stays under the radical. The 4 gets to come out of the radical. And that's it. The next one, example, I have a number out in front already. So if there's a number out in front already, guys, it stays out in front. Plain and simple. If there's already a number in front of the radical, it just stays there. Okay. For now, though, let's see what perfect square goes into 45. So I look at my perfect squares. Half of 45, you know, is 22 and a half. So basically, I'm going to check every perfect square under 22. The first one to check would be 16. 16 doesn't go into 45. The next one down is 9. 9 does go into 45. So I'm going to break this one down. The 5 is just going to stay out in front. Okay. But the 45 gets broken down into the square root of 9. I'll put that a time symbol in between that because that's what it means when it's written beside it, is times. So I'll put a time symbol there. 9 does go into 45, so it's 9 times what? Oh yeah, it's 9 times 5 to equal the 45. So because the 45 is under the radical, notice both my 9 and my 5 over here are under the radical because it has to stay there until I actually do the square root. So now I can do the square root. I can do the square root of 9. Okay, the 5, it was out in front, so it stays out in front. The square root of 9 is 3, and then I can't take the square root of 5, right? It gets me a decimal, so it's got to stay under the radical sign. And now just multiply those numbers that are in front. You already had the one number in front, so you have to multiply that by the number that you just put in front, the number that got to come out from underneath the radical sign. 5 times 3 is 15. So my answer is 15 radical 5. All right, so we're going to do some practice problems with that, but first we want to see how this might help you understand a little bit better. We want to see how that works if we're working backwards. Okay, it says square the number in front of the radical to put it back under the radical sign, and then multiply it by the number that's already under the radical. So for instance, they're asking here, you know, if we have this problem and we know this is the answer, this is what it simplifies to, what was it originally? right? Well, to figure that out, you take that number that was in front of the radical and you square it to put it back under the radical. Okay, so 3 squared is 9. I've got radical 9 times radical 5, and that equals radical 45. So really, this was the original problem. This was the answer. We're just working backwards. Well, what if we know the answer? What was the original problem? What kind of irrational number were we looking at to begin with? So here, we'll just follow those steps, right? The number that's out in front of the radical, we'll square it to put it back under the radical. We'll bring down the number that's already in the radical, right? Well, 2 squared is 4, so really this is radical 4 times radical 3, and 4 times 3 is 12, so I can put those both together under the same radical. So it's kind of like combining like terms in a way, right? They both are under the radical. We'll multiply them together. I can multiply them together under the same radical. 4 times 3 is 12. That's it, right? For the next one, I'm doing the same thing, right? To get the 6 back under the radical, I've got to square it. Bring down your other radical number, radical 2. So I'm multiplying those together. 6 squared is 36. So really, I have radical 36 times radical 2. And 36 times 2, right? I can combine those underneath the same radical sign. 36 times 2 is 72. So really, the original problem was radical 72. And then last but not least, example number 8, I've got 5 radical 5. Follow that same process. Square the number out in front to put it back under the radical sign. Bring down the number that was already under the radical sign. That's what we're multiplying together. 5 squared, we know, is 25. So I have radical 25 times radical 5. And then I can put those together underneath the same radical sign. And 25 times 5 is 125. All right, so now your practice is on the next 2 pages. So the first page, we've got just the simplifying the radicals, right? And then on the next page is the working backwards to get the number under the radical. I'm going to do a few from both pages just to help get you started, okay? And the very first thing I'm going to do actually is off to the side here. I'm going to list out so I don't have to keep flipping back and forth between this paper and my notes. I'm going to write out the first 15 perfect squares off to the side. So I'm just going to do 1, because 1 times 1 is 1. 2 times 2 is 4, 9, 16, 25, 36, 49, 64. See if you can beat me. 81, 100. 11 times 11 is 121. And then 144 is 12 times 12. And now it's just those 13 and 14s. Remember the digits just switch at the end. So it's 169, 196, and then finally 225. So again, having all of those perfect squares off to the side, that's going to help me check to see which ones go into, or which ones are factors of the number that's underneath the radical sign. So let's start with, I'll just do like the first 3. So for 27, I'm trying to find out, okay, what times what is going to equal that. Let's check my perfect squares. Half of 27 is 13 and a half. So let's check every number under 13. That means I'm starting here at 9. Oh, good, because 9 is a factor of 27. 9 times 3. So I'm going to do radical 9 times radical 3. I can take the square root of 9. Right? So I'm going to do it. The square root of 9 is 3. It gets to come out from underneath the radical sign. And then radical 3, can't do that. You get a decimal. So that's going to stay under the radical sign. And there's my first answer. Okay? That's all we're doing, guys. So just finding out what factors go into the number. I always start with half. So this number is really close to, let me write out my radical signs there. This number is really close to 400. So I'm going to start with every one that's under 200, right? So I look, okay, well, the first one under 200, geez, that's almost all of them, 196. So 196 times 2. Is that 392? Let's double check that really quick. 196 times 2. 2 times 6 is 12. It ends in a 2. That's a good sign. 2 times 9 is 18, but add 1 is 19. And then 2 times 1 is 2. Add that 1 that we carried. Look at that. It's the very first one I checked. It wasn't nearly as much work as what we thought. So I'm going to do that. 196 times 2. Okay, 196 times 2, radical 196 times radical 2 equals the same thing as radical 392. But I know the square root of 196, as we said before, it's 14. It's the 14th perfect square. That's how I knew it was 14. So I can pull that 14 out from underneath the radical sign. Unfortunately, the radical 2 has to stay under there because it gives us a decimal. Okay. All right. Now I know that you guys know the square root of 36 is 6, okay? But I want to show you what happens if you're doing these and this specific situation shows up, right? So let's say you just somehow forgot. Whoop! I forgot that the square root of 36 was 6, so I'm just going to follow Mr. Hilgert's advice and take half of the number. Half of 36 is 18, and I'm going to check every square root under, or I'm going to check every perfect square under half to see if it goes into 36. So you start, you're like, okay, so 16, yeah, 16 doesn't go into 36. 9, yeah, 9 goes into 36. So I do, whoops, I'm on eraser still. I do radical 9 times what equals 36? Oh yeah, it's 4. So radical 9 times radical 4. And 9 was the one I picked. I know the square root of 9 is 3, so I'll bring that down. And then I'll bring down my radical 4, just like I have for every other problem, and I'm done, right? Well, look at that. If you end up with a radical number and you think you're done, but you look at the radical number and you're like, oh, wait, I can do the square root of 4. Then do it. Then do it, right? So I know the 3 is going to stay out in front, but this square root of 4 is 2. And remember, when they're written beside each other like that, that means multiply. And look, I still get the same answer doing it the long way, right? So if you happen to not pick the largest perfect square that goes into a number, that's okay. You'll still eventually end up with the same problem, with the same answer, but don't think you're done. Check your answer. Use your brains. Think a little bit, right? If I see that this is my answer, that can't be right. I can't be done with that one. The square root, the number that's under the radical, I can do. I can do the square root of 4. Right? And then I get 3 times 2 is 6. Okay? So just double check that with all of the rest of these problems. Work through them. Pick the highest perfect square that goes into the number and make sure you multiply. See how you do. But if you get your final answer or what you think is your final answer and you notice, oh, wait, I can do the square root of that number that's underneath the radical, then go the extra step. This is our real answer, right? Not this one. Not this one. I'll actually erase it so it's not even part of the answer. We just know that the answer is 6 for number 3. Okay? I'm going to skip ahead and let you guys finish those on your own. Remember to check the answer key to make sure you're doing them right. But I'm going to do a few on this page as well, just to remind you of how to do the ones working backwards. All we're going to do is square the number that's outside the radical sign to put it back under a radical sign. And of course, that's being multiplied by the number that's already underneath the radical sign. Well, 4 squared is 16. So I have radical 16 times radical 3. I can put both of those under the same radical. And 16 times 3 is 48. Right? Same thing for number 10. Square the number that's outside the radical sign. So I've got 7 squared to put it back underneath the radical sign. So I really have 7 squared is 49. I really have radical 49 times radical 3. I can put those both underneath the same radical sign. Not 7. We got rid of the 7. It's 49 now. 49 times 3. And that equals 147. So my answer is radical 147. And then same thing I'll help you with number 11. Square the number that's outside the radical already. to put it back under the radical and then bring down the number that is under the radical. 9 squared is 81. So I have radical 81 times radical 2, and I can put those underneath the same radical. 81 times 2 is 162. So radical 162. All right, guys, if you have any questions, make sure you ask your teachers.